Shall I start, sir?
Okay. Proceed. Record finish.
Nirmala ma'am. A very pleasant and cheerful morning to one and all present here. It is said that the aim of education is the knowledge, not of facts, but of values. On occasion like this, we are given wonderful opportunities to broaden our understanding, gain new perspectives, and strengthen our learning beyond the classroom. I feel truly honored to stand before you and compile this event organized by our department. Event like this serves as a bridge between academic learning and real-world applications, allowing us to interact with distinguished experts who inspire us to think, question, and innovate. Before I begin, I would like to extend a warm and hearty welcome to our respected principal, Dr. N. Anbucharian, Honorable Dean, Dr. K.K. Tyagarajan, beloved head of the department, Dr. P. Erumalai, distinguished faculty members, and my dear students. On behalf of R.M.D. Engineering College, I am delighted to welcome you all to the Generic Talk series on cloud-based overview of medical imaging and privacy standards, organized by Department of Computer Science and Engineering of R.M.D. Engineering College. It's truly a pleasure to see such enthusiastic participation. To begin, I would also like to welcome our beloved principal, Dr. N. Anbucharian, whose vision and leadership continue to guide us in our pursuit of excellence. Thank you for being the driving force behind all our endeavors and for supporting our efforts to organize events that enrich our knowledge and skill. I would like to extend a warm welcome to our esteemed guest, Mr. Muralidhar Chowdary, Senior Key Experts at Siemens Healthineers. We are incredibly fortunate to have you as today, sir. Your presence is a great source of encouragement for all of us, and we are eagerly await your inspiring address. A heartfelt welcome to our HOD, Dr. P. Erumalai, whose dedication and commitment to nurturing and shaping young minds is commendable. Your guidance plays a vital role in all our accomplishments, and we are grateful for your unwavering support. I'm happy to welcome all our faculty members, students, and all participants to this session. Once again, a warm welcome to all of you. Let's make this day memorable with our participation, engagement, and celebration. Leadership and learning are indispensable to each other. One such inspiring personality is our beloved head of the department. His guidance has not only elevated academic standards, but has also shaped a generation of students to strive for excellence. I now request our respected HOD, Dr. P. Erumalai, to introduce today's guest speaker. Please, sir.
Good morning, madam. Thanks. So, very good morning, one and all present here. It is my time to introduce our today's chief guest. It gives me immense pleasure to introduce our chief guest today's generic talk series, Mr. Muralidhar Chowdary, a distinguished professional and a true visionary in the field of medical imaging artificial intelligence. Mr. Chowdary brings him over 2 decades of rich experience in software research and development, specializing in medical imaging algorithms, AI platform architecture, and advanced visualization technologies. Currently, he is serving as a senior key expert at Siemens Healthineers R&D, where he leads to productization of medical imaging algorithms, playing a vital role in the transforming innovative research and practical clinical application that benefit radiological assistants and healthcare professionals worldwide. Over his 19 years journey with the Siemens Healthineers, Mr. Chowdary has taken on multiple impactful roles, including consultant, architect, system architect, senior key expert, consistently contribute to innovation, technical excellence, and leadership. Before he joining Siemens, he was part of the Honeywell Research and Technology Group, where he worked on a smart video analytics and retrieval engine, developing analytics such as fire and motion detection using infrared cameras. His work there earned him to patent for video-based fire detection. His core experience spans a wide range of domains, including medical imaging AI algorithms, DCOM and IHE standards, cloud and edge AI inference platforms, augmented and virtual reality for imaging and advanced visualization frameworks. In addition to his technical contributions, Mr. Chowdary has served as an official Siemens trainer, delivering specialized sessions on parallel computing and DCOM. He has also presented a numerous Siemens internal conferences and hackathons, sharing his insights and inspiring innovation among peers groups. Additionally, academically, he holds an MTech degree from VIT, completed in 2004, and is currently pursuing a part-time PhD at NIT Puducherry, further demonstrating his passion and continuous learning and research. His area of interest including image processing, computer vision, and the computational aspects of medical imaging algorithms, medical algorithm field that continue shape and future of AI healthcare. With two patents to his credit and a career marked by dedication, innovation, and impact, Mr. Nakini Muralidhar Chowdary truly exemplifies excellence in convergence of technology and healthcare. Dear faculty members and students, please join with me in extending warm welcome and a virtual welcome to our chief guest, Mr. Nagini Muralidhar Chowdary, a senior key expert, Siemens Healthcare and R&D. We are deeply honored to have you with us today, sir. Let now welcome our Nagini Muralidhar Chowdary to take us through this enlightening session and share with his rich experience. Thank you for joining with us, sir. I welcome once again. Thank you for the opportunity, 100% faculty members, students. So make this session fruitful for all of our future endeavors. Thank you, sir. Thank you for
sir.
all.
Thank you, sir, for your kind words. And let's start the session. Maybe today, so we'll discuss on the some of the amazing standards which we in the hospital context. I mean, we might be going to hospitals, we might be looking at different departments in hospital, but we might not know what what are the different software systems behind this hospital, running behind the hospital. So let's go through that, and what are the different standards they implement to make it more interoperable. So yeah, so the agenda will start with some overview on the healthcare IT market, and then discuss on the different devices and software systems in a hospital typical, and we'll go through some typical hospital workflow, I mean different systems, how they really work, and then we start with the diagram medical imaging standards, and then finally we'll just discuss something on the privacy standards also, which is also even equally important. Okay, so if you see this healthcare IT market, the growth actually is increasing year by year. If you see here, some 2018 to 2030, so the market has been steadily increasing at a rate of 15.8%. So, and the current market size itself is $663 billion USD dollars, and it is projected that by 2030 the market size will go to $1,800 billion. And of course, when you see this, the whole stake, if you see North America is the largest market stake in that, takes in that, and followed by the Europe, and then goes to the the Asia Pacific region. So overall, when you go to the when they have some statistics by 2034, it goes to $3 trillion dollars market rate. So when I talk about healthcare IT market, means the softwares behind running this the devices and the hospital environment. So that's what I mean is, yeah. So let's see what are the different devices. First, different devices. When you go to the hospital, I think you might have already seen these kind of devices. Like you have a set of scanners, like ultrasound. You have scanners like CT and angiogram, and you also might have seen this for the cancer therapy. They just use the CT PET and all. And you also might have seen this kind of device like a dicom print, where you have a film sheet which you get as a film sheet. After getting the scan, you will get as a the output as in the form of film sheet also, right? And also we have some kind of a review workstation where the radiologist will sit and do the reviewing of the scanned images. And also some of the cases, some of the the complicated cases, they just go for this doing post-processing analysis. They just do, and wherein they just do the 3D analysis like volume rendering and all, which makes it get more inferences there. I mean, so they apply these algorithms to infer some more details there. And yeah, so and I think you might have seen some device like ECC also, wherein you get electrocardiogram, how to know about how the heart is functioning and all. And I think you might not seen this thing, PAC system, which is actually a storage system which is sitting in the hospital somewhere. I mean, which really takes all the images which has been generated by all these scanners and then stores it to this. So this is a kind of centralized system which is sitting in the hospital. Another side, I think pathology, I mean the laboratory side, if you go, I think you might have seen the different analyzers. I mean, for the blood actually samples, if you're really doing CBC, central blood count, I mean clinical blood count actually. So you go for this hematology analyzer and there's a chemistry analyzer and this immunoanalyzer, which mainly for this the hormones and all, it just detects even thyroid will just be detected with us. So these are the different devices which you see in the laboratory side, and these are the different devices you see in the radiology side in the hospital, right? So if you see, when a hospital procure these machines, it doesn't mean that they have to purchase all these machines from a single company, right? They will just get the best ones from each one company, because each company, medical device companies, they are maybe good at manufacturing certain products, but they might not be good at another. So you might procure a Siemens CT scanner, which is the best scanner in the market as of today, and they might purchase a G for PET scanner. I mean, PET scan, CT PET scan actually, and you can go angiogram, some other company. So you could even go there, right? So, and coming to this, apart from these devices, there are some software systems also there sitting in this hospital. So if you see, look at the hospital's software systems, um, one of the main thing is hospital information system, HIS we call. So there's a main software system, which is like a heart of the whole software system, which connects to the different all other software systems. So this does both administrative activity. I mean, it handles the administrative part of the hospital, at the same time the clinical part of the patients, all those things, it will take care of that. It handles it. So right from the patient registration and I mean to the end of the patient discharge time, so it will take care of all the things, right? And followed by, there is another software called radiology information system, specifically to radiology department, and so wherein you get requests of getting scans from for different modalities like CT or MRI or X-ray. So it just get the information from the HIS that this patient has to undergo so and so scans, and you do the scanning, and followed by storing the results into some centralized system, archiving system, which is called PAC system. So, this typically these hospitals, they will store the data almost some 20 years. I mean, there are agreements that this PAC system has to be stored the data for almost 20 years time period, or sometimes 10 years minimum. So they will keep some limit on the time. So they want to have store such a huge time period, they'll store it. So this is a crucial thing. PACS is a crucial system which stores all the data from all the modalities, which just comes and stores in this. This is a centralized location. And followed by, there's another important software system, which is mainly related to the laboratory side, wherein you really go for the clinical tests, actually go for that blood tests or urine tests or uh, serum tests, and also you go for all any tests actually. So it starts from this laboratory information. So all this laboratory information system will take care of the managing of the tests right from the order, getting the order from the HIS, and it give the order, and then make the analyzers to run the order. Of course, once the specimen has been taken by the performance actually, so then what he does, he just put a barcode. I think you might have remember that he'll put a barcode thing, and then based on that, he just put this barcode, the specimen into the analyzer, and then once the analyzer did that test actually, and it just get the result, and it send the results back to the HIS. The other one is a pharmacy information system, wherein related to the pharmacy part. I mean, another thing I think intensive care unit, which different devices in intensive care, where the patient monitoring systems, many things will be there in intensive care. Of course, they all have even the mobile X-rays also will be sitting there in the intensive care. So, and even there'll be sometimes the CT scan. I mean, also will be sitting in the ICU itself directly. So, in such systems, to orchestrate all those things and then ensure that you get all the informations from there, and then keep that clinical workflow. So they use this software, special software called intensive care system, and this will also connect with the hospital information system. Yeah, so if you see in a broader way, if you see the higher level, like hospital information system will be the higher level software system which will be sitting there, and which does some administrative activities also. It does also the registration, but it also connects with this software systems like a RIS, radiology information system, lab information system, pharmacy information system, and ICU information system. And there is something, some other hospital has even more information like nursing information system also. There's some softwares. Actually, this is a broader way I tell, but in some hospitals, in bigger hospitals, you'll have this clear distinguishment between these software systems. But in smaller hospitals, there is always they tries to keep everything in one single software system, which so it could happen that in some hospitals it will have a HIS and RIS on the laboratory information sitting in the same software system, which maintains everything there. But in a bigger hospital, they maintain it totally different. And yeah, so it again depends upon the scale of patients coming and how much tests they undergo and all those things. Yeah? The load of the tests. So a typical hospital workflow, how it looks like when a patient enter into the hospital, what he'll do first is he'll do the registration of the patient, right? So what he'll do, he'll just go to I mean, there is a software system is called HIS hospital information system, which will do the registration. And then what you do, you go to the physician, and physician look at you and then see the symptoms, and then say, go to he just orders some kind of some clinical lab tests, and at the same time some imaging tests, right? So some blood tests he wants to do, and he will ask you to go to the imaging tests. I mean, like just go for a CT scan or MRI scan or just X-ray scan. So they'll ask you to, right? And then followed by what happens is, like after the scan, actually, so what he'll do is, based on the recommendations, it will send for laboratory, it will send to LIS, laboratory information system, and for the radiology information, if you are doing a scans from so now the modalities like X-ray, CT, or MRI, so it just go to the radiology department, so which where the radiology information system sits actually. So what LIS will do, the lab information system, just once they get an order saying that so and so test has to be done, it just perform the test using the analyzers which is sitting in the hospital. Like it could be a chemical analyzer or immunoanalyzer and all. So or hematology, right? And then sends the results back to the HIS actually, and as a report. And also the same is the case for the RIS. Actually, RIS completes the study. I mean, the scan. I mean, the study and the radiologist reports. I mean, once the scan has been taken, there will be radiologist sitting in the radiology department who will do the reporting and send the results, the findings. I mean, here the findings or abnormalities or something. So in the form of HSL, or it could be a DICOM as a format. We'll come back to that. What is this ORU talk and what is this DICOM and all those things. So finally, what actually does, he still aggregate all the results. I mean, and keep it in one system, which is called electronic records. And this health records, so health records will be visualized by the physician, and then he will just give the this is the full-fledged unified diagnostic summary. So then he will do the next steps, recommend the next steps. So let's go a little deeper and go into the radiology department. That's what kind of steps will happen in the radiology department. Like as I said, actually, the hospital information system is the first step actually. So where in the hospital information system, we give the order to the radiology information system saying the do so and so imaging tests, like it could be X-ray or scan, or it could be CT scan or MRI, so and so, with so and so protocol. They'll mention it clearly, right? Protocol means it just like tells that CT abdomen test, or it could be saying that CT chest test, or it could be CT brain or MRI brain test. You can So with some protocols filter, so they'll just once the radiologist information system gets information, what it does is just informs the modalities to update the work list. Means work list means like the list, so the order in which the scans has to happen actually, and it just also gives the patient ID and all, just gives to the modality, so that once the patient arrives here, he'll just get the scan here, and automatically once the scan completes, and then it just the modalities updates them is saying that the scan is completed. And once the modality is complete, the scan information, the scan images, I mean, in this case, it's radiology information mainly in the images, right, which is of more of pixels. It could be a 2D images like a chest X, or if it's a CT or MRI, you just go 3D imaging, right, 3D volumes. So what happens here actually is like you try to send the results into some kind of a storage system. What I talked about is a PACS, picture communication system. So this is a centralized storage system. All the modalities which captures the data, I mean the images, it stores into this PACS system. And finally, the radiologist, once the data comes, and he'll just try to radiologist will start checking the reports. I mean, he start checking each and every acquisition data, and then he start doing the reporting. He could use a dictation, and then he'll do the reporting. So okay, and finally, once it does done, actually the whole thing, they review the image and write the report, and then the report will be stored here, and it will be sent also the notification to the HRS that report is ready for the given patient, wherein from his itself they can retrieve and see the reports also, along with some images also. You can see it. Okay. Yeah, so then the similar case for the laboratory information system, wherein we have a HAS system, which is since the order, actually assume this person wants to go to central CBC test, actually, I mean, blood test you want to go, or a liver test, or a kidney, I mean, renal functional test, actually, if you want to go, and then HAS will give an order, actually, saying that just perform this test to the LIS, laboratory information system. Laboratory information system will actually, it sometimes directly talks to the analyzers. Sometimes it will use a middleware system, and then through middleware just talks to the chemistry analyzer or hematology analyzer. In this case, they use the hematology for the CBC, and since there's a liver and liver functional thing, and kidney functionality to check, actually they use a chemistry analyzer, so they use that. And what happens here, usually the phlebotomologist will come and collect your samples and barcodes it, and then send, and with just put a unique barcode ID will be there, and then it will send it to the analyzer. Analyzer will do the test, because the barcode contains the patient details plus and also what kind of test it has to. So based on that, actually just route the sample to the hematology or the chemistry analyzers. Okay. So, and finally, it just sends the results back to the HL7. So, I mean, through HL7 it sends to the HIS. So another one which takes a pharmacy information. So let's assume that there is an inpatient in the hospital, and doctor wants to give an antibiotic order. I mean, so he wants to administer some antibiotic. So doctors orders some cetaflexin kind of an antibiotic, and for 5 days actually. So he's in this RD, which is an order actually, which is a command for sending an order. And so for the second step is it will send it to the pharmacy information system, where this pharmacist will start looking at whether there's a stock inventory is there or not, validates the stock, and then it updates the status of that. And also he will once he dispenses the pharmacist dispenses that medicine to the department where he has to do, and the nurses will do the administration. So once he did the dispensing, he'll send a response saying that the medication has been dispensed to the department which is mentioned, and at the same time nurse department where nurse will do actually administer the real the injection IV, and then they will just update the status in the HIS menu. Okay, and of course there is the final thing is a cost consolidation billing. So wherein whatever cost happens for all these activities, they'll just update through like HL7DFT, so which is a financial transaction, detailed financial transaction. So all these things, actions, traceable within medical administration record, we call actually in the hospital. Okay, so now we talked about different the software systems in our thing. Now let's see the standards, where actually the standards are required in a hospital now. So let's come before we go to this where we go to that, why we need a standards first and foremost. Like, let's see, now we have as you in the starting where I mentioned that different hospital contains different devices from different companies, and if the data has been created, if they everyone started creating their own formats, and one person cannot able to read the other's format, right? So they need an interoperability is most important here. Another important need of the standard is like data consistency. So now I talked about HIS, the hospital information system, and then I talked about radial information system, I talked about lab information systems. So, and even the ICU. So now if we really want to keep if the patient goes all these three departments, now if everywhere, if you're just adding the patient name and patient date of birth and patient sex and given ID, so if you add it, actually the problem is could happen that it could end up in creating a duplication of it. So you will have to do the duplicate data, do the multiple times you have to enter it, right? So there is no consistency in the data. So it could happen that there will be errors, so it will lead to a patient safety. So it could happen that some radiology information system he kept as his name as a different, and hospital information as a name as a different, and his age is also different. So sometimes he put male, another side puts female. So it'll be a problem, right? So another thing is workflow efficiency. So every time you start adding the data in every department manually, so it will end up in a work. The efficiency of the whole workflow will go down, right? And again, the legal regulatory compliances, you have to really, when you are following this software systems, you have to really follow this legal and regulatory compliances, wherein whenever you change the patient name, even if you go emergency patient, usually, when a person has been gone to emergency system, emergency department, so usually they'll not write a patient name, because you are not in a situation that you will ask what is your name, right? So they'll create only unique patient ID to them, and then you just do the scan, and they'll just do all the procedure, and then later they'll just do the um, they'll update the patient name of that. Once it comes to a stage, then they want it, they will add it a patient name to that. Okay, so at one, I mean, emergency, they will not add a patient name or things, his date of birth and all that. They'll just put mandatory, which is patient ID. They'll tag it to him to a particular ID, which should be common to every department. Now, after some time, when you just update the patient ID, patient name, you have to update in every department, right? So that's what actually the legal and regulatory. So you have to make sure that his name has to be updated properly, and the data also has to be has to be exchanged across the departments, not just across the departments, or it could have been different hospitals also. Like there'll be multiple hospitals in the or chain of hospital for a given hospital itself. So you want to retrieve the data from there, and from one hospital to hospital A to hospital B, then you should have a mechanism for to getting the data in a standard way, right? So you should be able to, or assume that you are data scanning in the CMC and you want to extract the data from in a different department in the different hospital, then you should be able to have a means to extract the data. So that's where we need the standards there to the. Okay, so let's look at what are the areas. I mean, we discuss on why we need standards, but now we discuss what's the areas where we really need the standards now. So more in the starting, we discussed about different devices in hospital, wherein we have a different scans. I mean, different scans. I mean, scanners. It could be a CT scanner. I mean, he might have purchased from Siemens actually, and G. I mean, he MRI scanner he might have purchased from G, and the Samsung. They use ultrasound scanner for from Samsung, and X-ray from Toshiba. Assume that. Okay, now if everyone has to store the data into a centralized storage system, so whatever there it is, because they have to, a hospital has a contracts. They just say that we store the data for a patient for almost 10 years or 15 years or 20 years also. So if you want to store in a centralized system, so you have to adhere to some standard, right? Some kind of a standard way of storing the imaging data into the system. So the solution in imaging side is there's a standard called DICOM, and so the DICOM is a standard where you store the image or image related data into the centralized PAC system. So, and you can anyone who retrieves later can retrieve through if you are a DICOM compliant actually. So that's what it is. Another area in hospital where you need a standard is a clinical workflow. As I talked about you that the patient will start registration and he'll undergo that some kind of a test, some kind of clinical information. I mean, his clinical updates will be there, and his medications. and even his lab information, lab results, all those things, and all those things we have to store. Here we have to exchange among these systems, right? So this here they use this HL7, health level 7 is one of the standard where they use messages like ADT, different kind of messages this pass it across to have this standard. Okay, so this is the solution. I mean, the clinical side, the solutions are HL7 on fire. Okay, and DICOM. I mentioned here DICOM web. Actually, it's like it's a web variant of the DICOM, which actually, if you really want to through web, actually HTTP, it's like a REST APIs. If you want to call the data from REST APIs. They use a DICOM web actually, and I mean it could be used. You can say the cloud packs could be some nowadays new packs coming in the cloud also. The packs is nowadays the packs providers, they're storing in the cloud. So the whole data, imaging data, they store in the cloud system. So it's a cloud packs, and they just use this DICOM web standard to retrieve the data is in DICOM. DICOM data we can get to DICOM web, and the same is the case for Fire actually, wherein Fire is a new standard which is a web oriented of HSN. Of course, it has a much more, many more things. It's widely in use nowadays. I mean, so this is also web oriented of HSN. So, but normally DICOM and HSN works in a hospital environment in a TCP/IP, but DICOM web and Fire will works in the REST APIs. Okay, yeah, for the web. So now starts with the DICOM DICOM standard. Actually, let's start about. So DICOM standard once I mean when around 1980 they found most of the modalities started creating the digital data, because initial days actually around 1873 around the X-rays created. So these are all film sheets, and they are not a digital ones. Then later, over the period, the people started creating the digital data where they store this amazing data in as a files and as a pixels, as a part of pixels, and storing in the form some kind of format, their own proprietary formats. At what happened is around 80, where 1980, wherein they have a CT scanner, they have MRI scanners. What happened is everyone started seeing. I mean, these companies like Siemens, GE, and Philips, and all. What they do is they just started creating their own formats and storing it into the storage system. Now, what happened is, assume that the scanner is he purchased his Siemens, and the reader he's purchased is from different company, and he is not able to understand these formats. Now, then that's a place where they thought they should have a kind of a standard they want to. So in 1983, actually around actually this ACR, American College of Radiology, and National Electronic Manufacturers Association joined the forces and committee, created a committee. And 1985 is the first time they created this standard, which initially it's called as ACR NEMA 300, and the second 1988 is the second version of the ACR NEMA, and 1993 it's called actually it's renamed to, instead of called ACR NEMA, they call as a DICOM 3.0, and after that it's just followed by year updates like DICOM 2000. Currently it's 2025, so the standard name is for DICOM 2025. So the standards will be available in the DICOM site. NEMA, as they call this, is a site of the DICOM where you can find that DICOM documents, the standard documents also. So now understood. Now let's go to what are the devices in a hospital which implements really the DICOM actually, right? So what are the devices really implements the DICOM? So any of the image acquisition device, like it could be a modalities like CT, MRI, ultrasound. So they have to be implemented DICOM. So they have to be DICOM compliant. Okay. So it's not like they just send any file in a JPEG or BMP. No, it's not like that. They have to create a DICOM file. They have to be DICOM program. The way communication also has to happen through a DICOM way of communication. Okay, they have DICOM protocols only. So image viewers, the people who tries to visualize the DICOM, the X-rays or CT scans, they want to all these image viewers also have to understand the DICOM data. So they have to be there. And the diagnostic workstations and 3D visualization. Some of the places wherein you end up in creating a 3D visualization like volume rendering and all, wherein you can see the 3D view actually, and then cut the cross section and then see where exactly the lesions or tumors are there in that. So there also these devices also should understand the DICOM and all these things. And sometimes you really go for this DICOM printer. So print actually, so DICOM print, wherein you do create a scanner. I mean, you have a print system wherein once you have the images, you're trying to print in a film sheet, right? So this printer is also not just like a normal printers like inkjet printers, but it's a DICOM printers because the data what it receives is a DICOM files. I mean, a different format, DICOM file format. So it should able to understand the DICOM. So it should able there is a proper DICOM commands to send the film sheets actually in a layouts and all, and then it will be printed actually accordingly. And yeah, some other things like PAX, CAD, and CDM are also with the devices which are supposed to be a DICOM compliant. So now let's understand what actually DICOM does and what DICOM doesn't do actually. So you should ask me like why DICOM, when I say DICOM, what really it does and what it really not, it is doesn't tell as a standard, right? DICOM as a standard, it tells how to produce an image. I mean, what the way to produce an image and how to, I mean, produce an image as an image file. I mean, how it should look. When you have a pixel data, how to create a set, produce a file, image file system, and store the image. How to store the data. I mean, like if you want to store into the particular file system, as what you have archive system, how to store it, how to display it also. So how it also talks about how to display it. I mean, how it has to display like so another thing is how to send the data to another node, other DICOM node, how to send it. So there'll be a DICOM provider, there'll be user DICOM service class provider and service class user. They call there's a term called service class user and service class provider. So the user will trigger and saying send me the so and so image, and it will be able to get the images here. So that's how it's exactly. And you should also know how to query the data from the PAC system, so which is being stored actually. And it also tells about the standard talks about how to process the data and how to retrieve the data and how to also print. Print here means the DICOM printer. So here it means that, okay. DICOM, what DICOM doesn't talk about? DICOM as a standard will not talk about anything related to the implementation like data structures use. It doesn't talk about what language you implement. It doesn't talk about what is the hardware, what is the operating systems, or what kind of UI you use, graphical interface. It doesn't talk about that. So different parts of DICOM. DICOM actually has been 23 parts. This is the older diagram, which doesn't have all the parts, but it has more parts now. But if you see the majority, like the different, each part will talk about different topic in the DICOM actually. So part one gives the introduction of the DICOM and some overview of that whole standard. And part two is conformance statement, means if I am a medical device, if I implement a DICOM, and I should give my conformance statement to others so that he will understand what are the different aspects of DICOM standard I am implementing and what is my capabilities as a DICOM device. So that's conformance statement has to be there. Every product who is releasing as a medical has to give the confirmation statement. And part three talks about information object devices, like definition of information object, and it talks about all the CT, MRA, what kind of information it has to store, all of those things that are there. Part five talks about encoding. I mean, how the DICOM file has been encoded. And part seven talks about the messaging access, how this files is to be accessed. Because, I mean, that networking, you see there's 7 levels of the networking, right? So application layer and all. So DICOM sits on top of that application layer, right? So OSA layer, if you see that. So this messaging exchange, what kind of different commands you are using to exchange the data. Okay. Yeah, so sample DICOM is I just put one structure. So this is a typical CT scan. Actually, it's just been taken one of the slice of the CT scan. CT scan usually with 3D. It's a volume. Actually, it's not a thing. This is one slice of the volume. Okay, so if you see here, this is how it stores. Actually, there'll be a tag and a description. I mean, it's like a tag and value. It's like start with the tag value base actually. So there each tag will specifies what kind of information it stores. Okay, so these are standard tags, and there are some private tags also. So if you see, all the event tags are called standard tags, and the odd tags are the private tags. Steady date time, actually, so it talks about this. So this is a 008 and 0030 is the steady date time, and it's a value of what is the date and time it stores. And if you see patient name, also will be stored in some 0010 and 0010. It's a group and element we call, and it just stores in patient ID. Actually, this is how it is stores actually. Okay, so let's go to the another standard which talks. So this is about the imaging. Now I talk about another one which I talk about clinical data, clinical workflows like HL7. So HL7 talks about the clinical data exchange and communication system. So it mainly focus on the administrative tasks and also the clinical workflows. I mean, some messages like, like admission of a I mean, ADT we call, actually one message called admission, discharge and transfer, and other message called order message, like we order a particular type of test or something to the LIS or something. And it also something like ORU is called results, how the observations and results coming from the different systems. From it could be like lab. Once you did the lab test, the results will come as ORU. And the final thing, some other messages like DFT, like detailed finance. There are some other messages actually I just want to. So mainly the intention is to bridge between this hospital information, lab information, risk information, and pharmaceutical system in a seamless way as per the standard, actually, so that you can purchase his from Siemens and LIS from the GE and risk software from some other company, but still they able to communicate seamlessly work together. Okay, so standards wise, HL7 V2 was very popular, and then V3 came, but it was not so popular. When now the newer format is more people are going through versus a fire, actually. So and these two are XML based, but this is a text based things. Okay, HL7 V2 is widely used as of today, and but now people are transforming to fire thing. Okay, and different devices. I think a lot of devices in the hospital works. I mean, his, RIS, and LIS, all these things understands the HL7 language, and if not, they'll use an adapter which understands the language and send it to them. And nursing information system, ICUs, and billing finances and lab analyzers. Yeah, use it. And even at ventilators, also machines, they also sense their vitals. I mean, to back to the as an HL7 form. Okay, and so yeah, so and yeah, I mean, some even the point of care testing, like you are doing the blood sugar test, those things also will be sent back to as a HL7 messages, and even the ECGs and EEGs also will be sent to them. So sample HL7, just want to quickly give two samples to you, have feeling of what HL7 looks like. Is I mean, assume that a person has been admitted to us. I mean, admitted a patient. I mean that. So it starts with like this is how the message looks like. It's a textual message. It sends through a TCP layer, but on top of the TCP. So like a message actually, and it tells that from whom to whom, actually. Here in this case, his to list, hospital information to lab information system, you're sending it. What is the message it's saying? The A01, A0 means admission a patient, actually, and the patient ID. So what is the patient ID? So this is the ID of the patient. So patient ID, you just remember that any patient ID is the unique item in the hospital. Patient name cannot be unique, but patient ID, they'll make sure that it'll be unique. Okay, so there is also a concept where a group of hospitals are there and still they want to maintain. There's a master patient index. They use it to make sure that all this. I mean, the patient A one time he goes to CMC Vellore, and sometime he goes to CMC Chittor, and still he wants to have the same patient. So they will maintain a master patient index to connect these two patients and the same patient. So that's one way. Another one is the next thing is a PV1. Actually, that in this message they talk about a type of visit he's doing. He was a surgery. He went for a surgical reason, and he's recommended for an ICU. I mean bed, actually, for so and so, and his name is this, and he's a surgical thing. And type of thing is admission. ADM is an admission. In this case, is type of visit is an admission thing. So the other kind of a sample is like if it's a lab test, or if you're going that MSH, you write, and HIS will send the lab information system saying that perform these tests, actually, blood tests, right? So it just says, and then of course here also you have to mention as PID, because patient ID is the unique system. Yeah, and and you just mentioned that what is the details of the person and all those things. I mean the patient, and the OBR, actually this mainly observation request, which what tests you really want to do. So in this case, glucose and blood glucose things you want to do in this case. So this is how that HL7 message looks like. And as I told, like HL7, the newer format, newer standard, which now widely being used in hospitals, is a FHIR, actually, which is even web-based actually. So it's a RESTful-based APIs, JSON-based or XML-based, not like a textual thing like before what I showed. And it's focused on the lightweight and real-time healthcare. Its main intention is to that go for that actually. And actually, it's also used designed such a way that it can be used in mobile apps, wherein you have a client system which requests the data from the HIS to the mobile, to your mobile, to know what the different patients have registered today. If you really want to query the patients and all those things, you can do this FHIR thing. I mean, yeah, and then I mean the basic system is some resources. The new concept we come with the resource by, so they call as a unique. The granular entity is called resource in this FHIR actually. So resource could be a patient or observation or imaging or diagnostic, anything. It could be anything. So and because this REST in the REST APIs and some new entities like diagnostic report, no, so they say that this can be connected to the AI systems, new AI system. So it enabled AI inference results to make it much better. Okay, so different categories of resources will be there in the file. Actually, like some related to patient-related information, some related to clinical, some related to diagnostic, and some are administrative-related resources. So, what kind of resources? I mean, resources means a resource could be a patient, or it could be patient means patient-related information, or practitioner information, or organization-related. Who is involved in that case? Okay, so I'll just go through one quick small resource sample of how the patient resource looks like. I mean, if you see the resource is a patient, his name means his ID. I'm talking, this is the name of the patient is patient. I mean, the patient type is a patient, and ID is patient ID, which is very, very unique in the hospital, and name, his name, and the gender of the birth and address. Now, how the FHIR will work actually. FHIR client, assume you have a mobile app, you really want to query a hospital network, which of course has the data based with the clinical information of the list of the patients who's been there in the registered in the hospital. So client sends a request saying through a REST API, I mean, get so-and-so patient with so-and-so thing. I want to know the details of the patient with a given patient ID. The server will just will respond with a FHIR resource. I mean, as a response, it will send this. This is a FHIR resource response. As a response, it will send it as a JSON or XML file, and client apps display this into their own application. Okay, so and of course it just follows some authentication also in that. And I'm talking about, so now we talked about based standards like DICOM, HL7, and FHIR, right? So now there's something called IHE. So now you talk about DICOM. So these are individual standards. Now to make them work in a seamless way and to apply to a particular clinical scenario. So there is something called IHE, integrating in the healthcare enterprise, which will sit on top of these standards, which says that which tells how to use these standards to make a particular clinical scenario. Okay, I assume that I will just explain with the example maybe. So there are different profiles. Actually, schedule workflow, I mean, enables the proper order of management in stories. I mean, I'll just go through a small example, maybe that will be good for you. So I think you know this thing, like where you get a CD once you go for a scan. Nowadays they're getting CD or pen drive, right? So how do you really do that? So actually, it's like, this IHG portable data will tell about what are the different kind of information it can store, like DICOM reports it can store, what are the different DICOM images it can store, DICOM data which can be stored, and what are the different software systems it can access it. I mean, it can access this and understands this data. So CD should be in a format which should able to understandable by the printer, DICOM printer. The data will be the printer also. It should be the review station also at the time of the web content also. Okay. So this they'll ensure that these profiles will ensure that how to use this DICOM, different data of DICOM to store in a particular way, and then so that people who sometimes know the end user might not even have a DICOM viewer itself. So what you'll do, they'll put an optional DICOM viewer in the CD itself, so that he can load the DICOM viewer, he can load the images into the DICOM viewer, and he can see it. Okay. Another schedule workflow, I mean, other profile I'll show you that quickly. It's like a review workstation, like wherein first, what will happen when a hospital comes, as I told, like patient registration happens, it starts with his hospital information system. And once registered, actually, he will be ordered some tests or some scans. So in this case, assume that the risk actually is he'll do some kind of scans. So once he performs the scans, actually he'll store the data into the PAC system, and he'll finally reviewed by a radiologist in the review workstation. So this is the whole flow. So this profile IHE will ensure that how to use these different standards. If you see HIS to RIS actually is a HL7, RIS to PAX is a modality is a HL7, and modality to PAX is a DICOM, and PAX to review is a DICOM communication. So it will tell how what in this flow what are the different how these standards has to be used. So this IHE will talk about these things. So there are different profiles in different for IHE. So it is somehow related to infrastructure related like security of how to secure the data also, and radiology departments has different things. And the typical thing, I'll tell you one thing wherein you have a hospital, multiple hospitals, how to share the data across two hospitals. A person can go to first time to hospital one, and second time he'll do the scanning on other hospital two. So they store the data in their own database, and now how to retrieve the database from the different database, how to see in a one single system. So this is what they call PICS, PICS system XDS, how to store this in the data and retrieve them. And also now nowadays newer profile called AI machine learning. Now new things are coming in AI actually. So now many AI algorithms are running on the images and getting some lot of findings. Now how to store those findings? So this IHC standard will talk about a standard mechanism to how to store the results. So I think coming slides we can see. I mean this is just a quick view actually how the IHC will connect to DICOM and HL7 as a profiles. And now newer thing is called a Fire itself. Fire also has a IHE, Fire-based IHE, which is REST-based IHE profiles. So mobile hand devices or air-based reading part and all those things are there. So now coming to the AI, actually now we know people have been using a lot of algorithms to running on the CT or MRI to find the abnormalities, I mean, in the brain, or it could be chest X-ray, or it could be abdominal, or it could be prostate. So they find some segmentations, they could find the detections, classifications, and all. How to really store? The current challenges are like the AI results have been stored in people not storing in a standard way. They are just storing as a PDFs or screenshots or some unstructured way of doing it. Like no, there's no common way to store the confidence scores or the probability maps, right? So there are ways now standard also mentioning how to store those things. If you have in case of imaging side, DICOM SR actually is a structure report which stores when you find a lesions and like a lung lesions, like lung lobes, and you find a lesions. So it just allows you to store this lesion coordinates and volumes and measurements. This DICOM I would use let you to show. DICOM segmentation, I would assume that you have a segmentation, you created a segmentation algorithm and run in a chest lung and all. You find some kind of masses. So you can keep the segmentation mass and mention on in this IOD, so that whenever the viewing workstation comes, he loads the DICOM, he'll apply this DICOM segmentation IOD, and he will see where exactly the segmentation mask. This is very much in standard, so that any person, I mean, like Philips viewer or a Siemens viewer can understand your results of the AI, can understand. The same is the case for parametric maps, which stores the probability map, because in AI will just have the probability maps for each mixes, right? And again, the same case for the clinical workflow says sometimes if you did some decision support systems, you transmit a summary. I mean, you do results back to his, and so there are some messages which supports you. And Fire also has something called diagnostic reporting and observation, which have this capability to store the findings and then send it back as a REST API. And also, as I told, like IHE has a new work profile itself, which talks about the AI integration with the PACS and Fire. Now, I just will not talk more there. Here, I just already explained. Like there is something AI engine which you really do some processing of the image and then find the AIs and send the mask to them, and it will be stored as a DICOM SR, and it will be stored into the PACS. And the radiologist will look at the results. I mean, of course, the PACS will display the overlays. I mean, PACS actually will have the viewing also, so where it displays the results and the A results and all those measurements. So radiologist, what he'll do, he'll just look at it. Usually radiologist will see by himself and through the validation. Now AI is assisting him to check the validations and the measurements. It will just shows the abnormalities. Then he can just reject some things, and he can I mean, he can reject some of the false positives, and the rest he can accept it. And after that, he'll just stored as a using HL7, he can just create a report and send it back to the medical report. So this another thing, decision support system. Nowadays they are trying to get all the information from different things, not just imaging but he's also taking the lab diagnostics. Both you are trying to fuse it, right? And you are also taking the historical values, right, over the period of time, and then you are trying to find some kind of a report you're creating. So this here also the FHIR kind of guidance response is one of the things we can use it to store in the EMR. Yeah. So I'm coming back now. I'm just telling about the privacy standards. So sorry, I think yeah. So privacy standards. So HIPAA is one of the privacy standards because now we talked about the normal standards which talks about imaging and clinical. Now talk about the privacy. Privacy is also important, right? So HIPAA is one very common one, and it's for the US. It's mainly for the US laws actually. So ensuring the protection of the healthcare information, like mainly the patient-related information. They don't want to. They want to secure it. Okay. So so mainly talk about privacy, security, and electronic data transfer. And yeah, I mean, actually, it limits the who can view this and share the PHA information. So you can't let anyone to see who is this patient and who is this, what is his age, what is his sex. It does not do that, right? Especially some of the VIPs, they don't want to do that, right? So HIPAA will make sure that and all this standard if you're implementing. So it actually this standard, no, I mean. Ensure it impacts all these systems, like whoever is building his RIS and LIS and PACS, whoever is building this office, and they have to ensure that they have to apply to apply to this HIPAA when you're selling in US. Okay, when you're selling this office in US, you have to be compliant with HIPAA rules. Okay, and non-compliance legal and financial issues, I think, and it's again there's a body called OCR, Office of Consumer Civil Rights, which will be enforced by that. And another one which is very common in EU, actually GDPR, actually, I mean EU regulations, I mean governing personal data protection for privacy. It's little more than HIPAA, and applies even for personal information, not just medical also, because what he tells is like a patient, it's more patient centric, where say patient should agree. Once you take a scan, you should agree, he should agree what you are using this data. Means if you say that I will use this data for my AA analysis, something in hospital says that I will use this for my another analysis, you should first agree. You should get a consent from him, actually the consent from the patient first of all. And patient also could request or copy the deletion of the data when you do that. And data minimization is one thing, because you should not keep all the information of data show, because in the cloud, if you're storing it, you should show only whatever is needed to collect only. It's not collect all the information which is not at all needed and all those things. And patients should be able to move their data between the providers. Means assume that you take a scan in CMC and tomorrow you're taking the scan. You want to get the data from the CMC to the Apollo, actually. So this kind of portability you should be able to do. This GDPR make sure that even India also, I think you know this, Ayushman Bharat, so they are going with this kind of things. And yeah, and encourage mainly the de-identification, because and pseudo-anonymization, the research of it, because mainly this de-identification is like metadata plus pixel data. They'll just de-identify so that it will not identify which data belongs to which metadata and all these things. Yeah, and for persons who really wants to work on the standards, I mean, or if you are really working on AI algorithms, if you come across in medical images, and if you especially DICOM data, if you really want to, there are different libraries. I just want to add it for your if you are a student and who are working on your projects. Now I can recommend like some of the there are some open source libraries. These are open source libraries I just kept here, and different languages they have it, and which implements properly most of the standard. I mean, some of the things, not some of the things, but yeah, most of the things have been implemented by them. So DCMTK for C++ widely being used, and for if your people are using Java application, so you can use it. Go for the DCMCH, and RThank is one for C++. And if your people are working for C#, I think food icon is the best actually. And just like the same TK, HL7 is happy. HL7 is one for Java people, and Bumblebee is for the Kotlin, or even for Android if you really want to get Android mobile apps and all this, or even Java. And Happy Fire also has been there in Java, and Filin .NET SDK is meant for Fire, and it's there and implemented in C#. And whoever wants to implement their Fire clients, and they can use it. And that's it. I mean, yeah. Any questions? Maybe.
Audience, Nirmala.
Yes, sir. Yes, sir.
Any questions from
Any questions?
Faculty members. Okay. Proceed.
Yeah, I think that's the end of my session.
Yes, sir.
Thanks
Yes,
a lot.
thank you.
Thank you.
Let us conclude. Yeah.
Anisha ma'am? Manisha ma'am?
You proceed, Nirmala.
Yes, ma'am. Yes, sir. So
Hmm.
it is the time to end up the session. So it is my great privilege to propose a vote of thanks on this occasion. First and foremost, I would like to express my deep sense of gratitude to our magnanimous management for their constant encouragement and support in organizing events that enrich our academic life. I also wish to express my gratitude to our principal, Dr. N. Anbuchelian sir, our Dean K.K. Tyarajan sir, for providing constant encouragement and giving us an opportunity to organize this event. Your guidance is always a source of inspiration for all of us, sir. On behalf of our R.M.D. Engineering College, I would like to thank our today's speaker, Mr.Nagineni Murali Chowdary, senior key expert at Senior Healthineers, for taking this precious time. Apart from these Diwali celebrations, you have readily accepted. Thank you especially for this, sir. Thank you for delivering such an inspiring and thought-provoking address. A special thanks to our head of the department, Dr. P. Elumalai, who have always been a pillar for support and guiding us not only academically but also in organizing such wonderful events. Your tireless efforts and dedications are commendable, sir. Last but not least, I'd like to thank all the head of the departments, faculty members, and students for showing their interest in this program. I sincerely appreciate everyone who contributed to making this event a grand success. Once again, thank you all for being a part of this wonderful occasion. Let us carry forward the spirit of learning, collaboration, and growth that we experienced today. Wishing you all a wonderful day ahead. Thank you. Thank you, sir. Thank you so much, sir.
Thank you. Thank you all. Thank you, sir. Thank you all the coordinators, faculty members,
I'll stop
students.
the recording.
Thank you, Nanda.